Let's go back to our PowerPoint here. And our final class, nucleic acids, monomer, what is it? Nucleotide. And a nucleotide is shown here. This is one monomer. This is one monomer. And in the monomer, we have a phosphate group. That's one of our functional groups from our organic chemistry chapter. And we have a sugar here. It's either ribose or deoxyribose, depending on if we're talking about RNA or DNA. And then we have a nitrogenous base, and that would be A, C, T, or G if it was DNA, or A, C, U, or G if it were RNA. And we'll take a closer look at that here on the next slide. Also important topics, purine versus pyrimidine, and that is talking about the classification of this nitrogenous base. We'll take a look at some examples in the next slide. And then this idea of 5' versus 3'. So I want to show you that here because I have this particular enlarged nucleotide shown here for our viewing pleasure. And we're talking about 5 to 3, or 5' and 3' end. We're talking about the numbering of the carbons on this ring, this carbon ring, this sugar ring. We always start where the sugar ring is attached to the nitrogenous base. So remember I said whenever you have a ring and there are no atoms indicated, you assume they are carbon atoms. So here is our first, 1' carbon. This is our 2' carbon. Here's our 3' carbon. Here would be our 4' carbon. And there's our carbon right there. That's 5'. Ooh, that's pretty ugly. Okay, but you get the idea. All right. And we'll take a look at this a little bit closer when we look at how these nucleotides bond together to form the nucleic acid. Let's take a look at this slide. So first, let's look at pyrimidine versus purine. So purine are the adenine and guanine, and they have 2 rings, 2 carbon, and then there's nitrogens in these rings as well, being as though they are nitrogenous bases. We have lots of nitrogen making up these rings as well as carbon. But purines, they are double rings, and they are pure. I remember this, they are pure like angels, A and G. Oh, they have a double halo. Oh my goodness, they are just so pure and angelic. And then the pyrimidines are everything else. So cytosine, thymine, and DNA. And then I don't know what happened here. It's not racil, my friends. No, it's not. This is going to be ugly. Uracil. Okay. And that's an RNA. Okay. All right. And now let's take a look at the sugars. Okay. So remember I said that in DNA we have deoxyribose, and in RNA we have ribose sugar. And there's only one slight difference, such a tiny difference. You might be able to see it. They're very, very similar except for one atom is different. And if you noticed here on the 2' carbon, that is where the difference lies. So in ribose, the RNA sugar, we see that on this 2' carbon we have a hydroxyl group, an OH. Over here on the 2' carbon, we just have the hydrogen, the H. This carbon has been deoxied. Deoxied. The oxygen is gone. Whereas over here, the oxygen is present. Okay? So DNA versus RNA is the only difference as far as the sugar. And of course, the difference with the nitrogenous bases. We have our T, our thymine in DNA, and uracil in RNA. All right, and then looking at how these particular monomers bond through that phosphodiester bonding. Let's take a look at this slide. So here we have a monomer, a nucleotide, and it is going to bond to this particular area of the sugar, the 3' carbon. So we're getting back into that 5' versus 3' idea. So the phosphate is going to bond to the 3' carbon, making that sugar-phosphate backbone. Sugar-phosphate backbone. And this bond right here would be a phosphodiester bond. A phosphodiester bond. A phosphodiester bond. Okay, linking these monomers together. And let me just go ahead and I'm going to circle. Here's my phosphate, here's my sugar, here's my nitrogenous base. Here's my phosphate, here's my sugar, here's my nitrogenous base. So if I take my monomer, 2 monomers circled in red, and I look for the line that links them, this right here, this line is that phosphodiester bond. And when we talk about the 5' end and the 3' end of the molecule, whether it be DNA or RNA, we are looking at the carbon that is towards the top, the most, I guess you can say, anterior part of the molecule, and that would be the 5' carbon. Okay, and then if you look at the bottom, the one that is at the most posterior would be the 3'. So this molecule is running 5' to 3'. And again, that has to do with the numbering on the